Hello everyone. Today we're looking at isosceles and equilateral triangles, as well as the associated ideas behind them for congruency. So let's start with definitions. Isosceles triangles, we've talked about these in the past, but they're going to be triangles with at least two congruent sides. Legs, the two congruent sides of the isosceles triangle. Vertex angle, the angle formed by the two legs. So in this case, A here would be our vertex angle of the two legs AC and AB. Base, the opposite side of the vertex angle. So CB is our base because it's opposite our vertex angle A. The base angle, the two angles that have the same base as a side. So our base angles here would be C and B. So again, folks, A is our vertex angle, C and B are both our base angles. Isosceles triangle theorem. If two sides of a triangle are congruent, then the two angles opposite the sides are also congruent. That is to say that if segment AB is congruent to segment AC, then angle C is congruent to angle B. Let's say if this is congruent to that, this angle is congruent to that angle. And this, folks, is something I've been teasing, hinting at, alluding to for the past few weeks with regard to the relationship between congruency of sides and congruency of angles. The converse is also true. If two angles are congruent, then the two sides of opposite those angles are also congruent. That is to say that if angle C is congruent to angle B, then segment AB is congruent to segment AC. If C is congruent to B, then AC is congruent to AB. Let's take a look at some practice problems. Solve for x, and then find the measure of GFH. So we're going to solve for x, now we're going to find the measure of GFH. So right off the bat, we know that the full internal angles of a triangle must equal 180 degrees. Let's say that 180 minus 40 is equal to 140, and 140 must be the sum of whatever F and H are. Now because the leg, the side, GH, is congruent to the side, GF, we know that F must be congruent to H. So another way to think about this is that angle F plus angle H is equal to 140, and angle F is equal to angle H, which means then that angle F must be equal to 70, and then that angle H, which is equal to 11x minus 18, must also equal 70. So, solving for x in this case, we end up with 11x is equal to 88, or x is equal to 8. X equals 8, which we've done. Do x equals 8, and we previously solved for what f must be equal to. So we have solved for both the x, and we found the value of GFH. Number 2, solve for x. We have a small typo here on this angle here, but that's okay. It doesn't matter because we don't actually care about the angles for this measurement, for this problem. All we care about here, folks, is our congruency, because we have a congruent side here, congruent side there, which means that 6x plus 4 must be equal to 10x minus 8. So we're going to set up our equation, because all we're doing is finding x. 6x plus 4 is equal to 10x minus 8. Solve for x. Well, we're going to move that 10x over. We get a minus 4x there. We move that 4 to the other side. We get minus 12. Divide both sides by -4. X is equal to 3. Solve for x. We have solved for x based on our congruency, because this side is congruent to that side of this isosceles triangle. All right. This one got a few parts to it. Let's see how to best sort this one. All right. So firstly, we want to find the value of w, the value of x, and the value of y. Let's start off with this giant triangle here that's subdivided into smaller triangles. We want to find the value of w. So, information we can pull from this. We have congruency here. We're essentially looking for here. Call this purple, so we're looking at this triangle here. We have congruency here and congruency here, which means that this angle is congruent to that angle. So to find the measure of angle W, what we're going to do is take our 180, subtract 64 from it, and divide that by 2. And that's going to give us our measure of W, because everything in here needs to be 180. These two have to be equal, have to be congruent, because the opposite sides of them are also congruent. Which then allows us to say that W, once we solve for this, W is equal to 58 degrees. Next, we want to find the value of x. To do that, we're just going to look at this part here, just that angle, because we have this little box square thing there that says it's equal to 90. We also know that this side of that angle is equal to 58. So 90 minus 58 must equal our x value that we're missing. Well, if that's the case, then our x value there is equal to 32 degrees. Lastly, we want to find our y value. So we're going to look at this triangle here. And we have this side here being congruent to that side there, which means that this angle of x must be equal to this angle of 2y. So if x is equal to 2y and x is equal to 32, then 32 is equal to 2y, which means that 16 is equal to y. And that, folks, is isosceles triangles. Now let's take a look at the equilateral triangles. All right, so equilateral triangles, some rules and definition. Equilateral triangles are defined as a triangle with 3 congruent sides and 3 congruent angles. That is to say that AC, CB, and AB are all the same measurement, and angle C is equal to angle B, which is equal to angle A. Equilateral triangle theorem. If a triangle is equilateral, then it is equiangular. We've talked about this, I want to say 2 weeks ago, when we first brought up the notes, that equilateral triangles are also known as equiangular triangles. Now we have the official theorem for what we talked about previously. The converse is also true. If a triangle is equiangular, then it must be equilateral. So, to summarize, folks, on these little graphs, on these little shapes here, in an equilateral triangle, all of our angles are going to be equal, and all of our sides are going to be congruent. All right, so let's take a look at some guided practice here. Find the value of x, and then find the measurement of angle h. Now, because this is an equilateral triangle, because all of these sides are congruent, we know that all of these sides must also be congruent. I'm sorry, all these angles must also be congruent. Well, the internal angles must be equal to 180. 180 divided by 3 equals 60. So each of these angles must equal 60. So 60 must be equal to 8x minus 4. And if that's the case, then we add 4 to both sides. 64 is equal to 8x. Divide both sides by 8. 8 is equal to x. And because h is part of an equilateral triangle, it must be, by definition, 60 degrees. Number 7, find the length of AC. Well, using our equilateral triangle theorem, we can identify that the measure of AB is equal to the measure of BC, which is equal to the measure of AC. So while we don't know what AC is yet, we do know that AB is 6x plus 3. We know that must equal 8x minus 11. And we can use these two sides to solve for our x. So we're going to move the x's to one side, end up with 2x over there, move our other values to the other side, leave us 14, or x is equal to 7. Well, x equals 7, which means we can find the length of AC by just solving for either 6x plus 3 or 8x minus 11. Either way, folks, we're going to find out that our AC value is equal to 45 because all of these sides will sum up to 45. Moving right along. Number 8, we want to solve for x. So we have an x value up here, looks like an exterior angle, y value over there. Is y value part of 9? Yep, it's part of 9. So let's take a look here to solve for our x's. First, we're going to establish the internal angles here must all equal 60 by definition of equilateral triangles. If we take a look at this on a broader scale, this angle here, this 10x, is an alternate interior angle to this 60 here. And alternate interior angles must be congruent. So we can say that 10x is equal to 60, because essentially what we have here are two parallel lines and a line going through them, such that this angle is congruent to that angle. It just so happens that in this problem, that also forms a triangle. So 10x is equal to 60, which means that x is equal to 6. We then need to find out what our y value is going to be. Well, based on our linear pairs, 11y plus 21, this exterior angle, plus this interior angle form a linear pair, which means they must equal 180. So we can write our equation as 11y plus 21 plus 60 is equal to 180. Or 11y plus 21 is equal to 120. Or 11y is equal to 99. Or y is equal to 9. All right, last two problems here, folks. We want to classify the triangles, then find all missing variables. For instance, number 1, we want to find the measure of RT. So a measurement of RT. Well, we've got a 39, a 39, and a 102, which means that because this angle is congruent to that angle, by the definition of isosceles triangles, this side is congruent to that side. So when we go to find our y value, isosceles triangles tells us that 5y plus 6 must be equal to 3 times 2y minus 2. Distribute that 3 in there so we can solve. 5y plus 6 is equal to 6y minus 6. Move our variables to one side. We have a y over there. Add 6 to both sides. We have 12 over there. So y is equal to 12. Knowing that y equals 12, we can then plug that back in to that, such that we have 5 times 12 plus 6. Well, that's going to be 60 plus 6, which is equal to 66. So RT is 66. Because even though we found RS must be congruent to RT. Let's write that out. RS is congruent to RT. All right. Given that AB is congruent to BC and congruent to CA, let's say that AB congruent to BC, congruent to CA. Find the measure of DB. Well, this is an equilateral triangle. Yay, touchpads. Equilateral triangle, which means all the sides are equal, which means all the angles inside are equal. So we're going to find our x value by saying any two of these sides equal to each other. So let's see, what are some nice numbers? Let's take AC and set equal to AB. So AC, 6x plus 5, is equal to 4x plus 13. Move those x's over, 2x. Move those other values over, is equal to 8. X equals 4. Well, find the measure of dB. Well, we have our A, our B, and our C, but we don't have a D. I'm assuming that the person who wrote this meant to put a D right there. So let's go ahead and just plug in, for our sake, a D right there to represent this point here. Well, if x is equal to 4, we can find the length of CB. Let's go back to our purple. Say that segment CB is equal to 8x minus 3, which we plug in that 4, is going to give us 8 times 4 minus 3, 32 minus 3, or 29. We have congruency here between these two, which means that D is a midpoint of CB, which means that DB, by the midpoint theorem, DB is equal to CB over 2, which is equal to 29 over 2, which is equal to 14.5. That, folks, is our isosceles and equilateral triangle notes. Please ask if you have any questions. Otherwise, please enjoy your day off tomorrow.